Okay, Algebra 1 fans, our topic for today, this is Chapter 2, Section 4. Solve equations with variables on both sides. Objectives after this lesson, students should be able to solve equations with variables on both sides. So what happens when you have x, or whatever your variable is, on the left side and the right side? That's what we're going to talk about. So, before we start, let me give you your joke of the day. Why did the golfer wear 2 pairs of pants? In case he got a hole in one. Get it? Hole in one? Now, to recall, remember that our goal is always to isolate the variable to get it by itself. So we want x equals a number, or a number is equal to x. That's how we know we're done. Before we move things, we want to combine like terms. Now, what's going to be different today, if you have variables on both sides of the equal sign, we will move the variables to one side using addition or subtraction because we're moving the whole thing. Now, let me explain what that is, and we'll take a look at number 1. So, we're going to solve 6x minus 3 equals 2x plus 9. I'll draw my line down, left side, right side. I want to get the variables on one side. So, we have a 6x on the left, we have a 2x on the right. I can move either one of these. I can move 6x to the right side, and I can move 2x or 2x to the right side. I am going to move the smaller variable. I'm going to move 2x. Now to do this, I'm not dividing, because I am not breaking apart 2 times x. I am not undoing that. What I'm doing is I'm moving this whole thing. This is a positive 2x. So to move it, I will subtract 2x, both sides. Now we can combine these. These are like terms. So 6x minus 2x is 4x. I haven't done anything with minus 3 yet, so I copy that, equals 2x minus 2x is 0x. Or in other words, that's gone, plus 9. Okay, equals 9. Now you'll notice that when I did the subtraction, I lined these up. I lined up my x's. I do not want to try to combine that with minus 3 because those are not like terms. So I'm going to be very careful here. Now, this is the type of problem that we did last notes. So now we have the variable on the left. Let's move the constant to the right. Now that's minus 3. To undo that, we will add it to both sides. Again, see how I've lined this up. We have 4x. Negative 3 plus 3 is 0. That's how I know I'm good. Equals 12. 4 times x equals 12. The last move is divide by 4. And we get 1x equals 3. Now what happens is that when I want to check this, I'm going to type the left side. So 6 times x minus 3. And I get a value, 15. So the left side is 15. And then the right side, I got to do the same thing. So now, 2 times x, which was 3, plus 9. Do we also get 15? We do. If the left and the right sides are equal, that means this is the correct solution. It made the equation true. So what you'll find is really there's one extra step here. We've got to move the variables to one side, and then it's just like what we did in the last set of notes. Now this time, I have 3x plus 10 equals 8x minus 40. Again, I want to move the smaller variable. I'm going to move 3x to the right side. So I'm going to do minus 3x. See how I've lined these up again so that I don't get confused and try to subtract them or combine them with this. That's 0x plus 10 equals 5x minus 40. Now the variable is on the right, so I'm going to move the constant to the left. So we will add 40 to undo the subtraction. 50 equals 5x. And the coefficient is 5. 5 times x. To undo that, we divide by 5. And we get 10 is equal to x. Okay, and then you can check that again and make sure the left side and the right side are the same. I could actually do this pretty quick in my head. 3 times 10 is 30 plus 10. So the left value is 40. And then 8 times 10 is 80 minus 40 is also 40. So it's good. Now you might be asking, well, what if I wanted to move the 8x first? Could I have done that? The answer is yes. I would have subtracted the 8x. It's a positive 8x, so I would subtract it. And what I get is negative 5x plus 10 is negative 40. I would go minus 10, move that constant to the right. Negative 5x is negative 50. Divide by negative 5. Negative divided by negative. We get the same answer. But what I don't like is that I have a negative coefficient. That's one more thing that I need to remember, that I have to be aware of. I prefer to keep it positive if I can. Sometimes we don't have that choice. But in this case, if I have the choice, then I will always subtract the smaller variable. Some people like to move the constants first. I don't, but you can. So if you have a question, just ask your teacher or me. Number 3. Again, I have variables on both sides. I am going to move the negative 12x because that's smaller than 15. Now to move a negative, we add both sides. Again, I line this up. 27x plus 6 equals, that's 0x, negative, positive, minus 21. We'll go minus 6 on both sides. 27x equals negative 27. Now when we divide here by 27, a negative divided by a positive, that becomes a negative 1. Okay, and that's your answer. Let me take a look at it here. Left side, 15 times x, negative 1, plus 6 gives us negative 9. And then the right side is negative 12 times x, negative 1, minus 21. And we get negative 9. We get the same thing, so we're good. Now on number 4 here, this one looks different because we only have one constant. 17x is already kind of by itself on the right side. So if I have the choice, I will move this x from the left to the right. There's no point in me moving 17x because then it's on the same side with the plus 8. Now this is a 1x. To move a positive 1x, we subtract it, both sides. So we get 0x. 8 on the left side, 17 minus 1 is 16x. And here you need to be very careful. You are going to be tempted to say the answer is 2. And if you do that, you are wrong. Because we are not dividing by 8. We are dividing by the coefficient, which is 16. So I have to divide by 16. 8 divided by 16 is not 2. That reduces to 1 over 2. 1/2, or you could say 0.5. That's also acceptable. Okay, so some of this stuff you can do in your head, but you need to be careful at the end. You don't want to make a mistake with that. Okay, we're dividing by 16. 16 is bigger. The answer is a fraction. Okay, 5. All right, problems are getting a little bit longer here. Before we move anything, look at the left side and notice that we have two terms with x. We have two like terms here. First thing we'll do is combine those. Negative 3x plus 1x is negative 2x. Plus 7 will stay like it is. And then I'm just going to copy the right side. So we have variables on both sides. I will move the smaller one, which is negative 2x. To undo a negative, we will add 2x to both sides. That's 0x, that's gone. We have 7 equals. Now negative 14, we haven't touched that yet, and this becomes plus 7x. Now we're going to move the constant to the left side. That's negative 14, so again to undo that, we will add, and we'll get 21 equals 7x. And then the last move here, that's 7 times x. To undo multiplication, we'll divide by 7. 3 equals x. Or you can write x equals 3. And if you check that, it will work out for you. Now, let's take one more here for the part 1 of the video. Now there's all kinds of stuff going on. The thing about solving equations, you have to remember it's the same rules. The rules don't change. So if you have a longer problem, you've just got to go one piece at a time. Before we move anything, we want to take care of like terms, or if you have multiplication, we're going to multiply first. We're going to distribute. If we have parentheses, we need to take care of that. So on the left side, we will distribute the 2. 2 times 5 is 10. 2 times negative 4x is minus 8x. Now don't forget, there is a plus 1x that comes after the parentheses. The 2 does not multiply that, but I have to write it. Equals, okay, now we're gonna multiply with a fraction here, distribute. On the side, negative 2 over 3 times 6x. And I'll write that as 6x over 1. So multiplying fractions, you multiply the numerators together and the denominators. That's negative 12x divided by 3. And if we divide that, we get negative 4x. So this is negative 4x. Then we have the negative 2/3, that's negative 2/3, times a negative 12. I'm going to write that as negative 12 over 1. If we multiply these together, we get positive 24 divided by 3, which is 8 plus 8. Now, can you use the calculator to do it? Yeah, sure, you can. Just to check the negative 2/3 times, I'll try negative 12 here. I personally don't like using the calculator. I'm going to do that in my head. But point is, we get negative 4x plus 8. Now we've distributed. Before we move anything, do we have like terms? Yes. Negative 8x plus 1x. Whoops, that's not positive. Sorry, that's negative or minus 7x equals negative 4x plus 8. Okay, variables on both sides. I will move the smaller one, which is negative 7x. I will go plus 7x, both sides. So we get 10. That's 0. This would add up to 3x plus 8. Now we move the constant to the right, so we subtract, whoops, not 2, subtract 8. I'm thinking ahead here. 10 minus 8 is 2, is equal to 3x. Last move is to divide, to move the coefficient, and we get x equals 2 over 3, or 0.6 repeating. Now let's see, this was a really long problem. We worked pretty hard here. I would like to check and make sure that this is correct. So when I type the left side, I'm going to type this whole thing exactly how I see it. So 2 parentheses 5 minus 4 times, our answer was 2 over 3, close parentheses, and then plus 1x, which was 2 over 3. The left value is 16 over 3. Okay, I'm going to write that down here. The left was 16 over 3. Hopefully the right side is the same. Now, when I type this, don't forget that is a negative in front of that fraction. So negative 2 over 3 times parentheses 6x, so 6 times 2 over 3 minus 12. Fingers crossed. Do we get 16 over 3? Yeah, look at that. So that means that the answer is 2/3. The reason why we don't round is that if you try to do 0.7, this will not be exact. These will not be the same. They'll be close, but they won't be the same. So we don't want to round that solution. And that is the end of part 1.